Welcome, everyone. It's good to see you again. How have you been? Ta-da. Okay, guys. Today we're going to continue with another application of the stress or pressure, but this time continue with the deformation of solids, and this time with the liquids. One of these applications when we're talking about with the Pascal principle. The Pascal principle, or in Spanish means Principio es Pascal, states that when the pressure is applied to an enclosed fluid, the pressure is transmitted and diminished to every point of the fluid and the walls to the container vessel. What does that mean? That means the liquid, they're going to acquire the shape of the container, and the pressure will be similar to the upward, downward, left, right, in every size in that situation, okay? So in this Pascal principles, we have to apply the concept of the absolute pressure. What is the absolute pressure? The absolute pressure, my dear students, is the addition between the atmospheric pressure and the gauge pressure. So what is the gauge pressure? It's the manual pressure that we're going to apply in one singular situation, okay? And as soon as you can see, the atmospheric pressure has a constant value of 1.013 times 10 at the fifth power pascals. This is the constant value of the atmospheric pressure. And the absolute PABS is the absolute pressure that we establish the relation between these two pressures. Is the gauge pressure or manual pressure is the pressure that we're going to calculate manually. For example, we have two formulas. One of them, the gauge pressure using function of depth, or if you want to say the applying force multiplying by the undimensional area. And this is similarly works another application, the formation of solids, but this time we're going to talking about the liquids. What will be the total pressure applying the liquids when there is inside a container or a recipient between the situation? Okay, so we have when we're going to apply this absolute pressure. The absolute pressure will be applied if and only if we have a container open to the atmosphere. But if we have a container close to the atmosphere, we are not including the air pressure or the atmospheric pressure because there is no air entrance, ni input or output, because it's sealed, as a matter of speaking. But if you have a container opens in the top of the part at the atmosphere, okay, there's gonna be an absolute pressure. All right. I don't know if you have questions onto this part or everything's clear. I have a question. Mister, I don't have Wi-Fi, so I am not using data. Okay, don't worry about it. I understand. Questions? Well, it's simple. And supplementary words, that equation, we're going to use if and only if we have a container open to atmosphere. But if we have a closed container, there is no necessary to include the atmospheric pressure. Okay? So in the first example, this is going to be the perfect concept or the perfect way how to use this equation. For example, the problem measure in container is filled to the depth of 20 centimeters with water. On the top of the water floats a 30 centimeter thick layer of oil with a specific gravity of 0.7. Remember the specific gravity, this that measures the quantity of water that a liquid has. And for that reason, there is no unit because it's a percentage. This is supplementary words. And the question is, what is the absolute pressure at the bottom of the container? Well, if the problem asking for what is the absolute pressure, that means this container at the top in the highest part of this container that will be open to the atmosphere. So what we're going to do? The first thing that we have to do, we're going to draw the container. a shape of the cylinder, and there will be a practical way to represent this situation. We have a cylinder, all right? Well, just like that. Okay, this cylinder is open. We have the top is open to the air. How do I know that? Because they're asking for the absolute pressure. So we have an interest of air pressure onto this situation. This air pressure we're going to call PO, air pressure, or atmospheric pressure in simple merely words. Okay, so continue with the illustration. The problem mentioned container is filled to a depth of 20 centimeters with water, right? We're going to say this is going to be the water, the blue one, the liquid, the blue one. This is going to be a water. And the depth, this depth will be included around 20 centimeters, or if you wish, 0.20 meters, okay? In this situation, we include water. And according to that problem, we have oil with 30 centimeters thick. That means this depth of the oil in the upper part of the water, that will be 0.30 meters. Remember, we cannot, according to the properties of the oil and the water, as much as we can, as we really want to desire, we cannot mix the oil with the water for their properties. So that's not possible to mix them. For that reason, you're going to assume the orange liquid will be represented by oil, okay? Water and oil. What will be the values or the data of the water? We're going to say, okay, this is water. Remember, according for the table densities, the density of the water will be given by a constant value of 1,000 kilograms per cubic meters. Okay, this is going to be the density of the water. And if we're talking about oil, remember, we don't have the density of the oil. Actually, we can look for in the table densities, but there's a one singular reason why we have a specific gravity. The specific, given specific gravity, that will be the quantity of oil we're going to have in presence of water. Remember the equation of the specific gravity. The specific gravity is the division between the density of the liquid divided by the density of water. And if you really want to know what will be the density of the liquid, is the product between specific gravity times density of water. Okay, I'm going to erase this one data. I'm going to copy below. So simple and barely words, GEA will
Yes.
be 0.7. Yes.
I don't know if it's only like me on my internet, but sometimes you hear like your voice fades when you're explaining a bit.
Yeah. Probably is the internet connection. I'm going to explain it again. Okay. Testing. Can you hear my voice?
Yes,
Yes.
right now,
No.
yeah.
Okay.
Yeah.
Let me check the audio. Probably I don't know. Not sure if the internet connection or probably will be. This is not a speaker. No, este no creo. ¿Cómo me escuchan ahora?
Like
¿Cómo
right now, it's clear somehow.
mejor?
Mhm.
Mm, bueno, que ahorita estoy usando lo que es el. Ah, ya, espera. Eco, ese es el audio speaker. O sea, estoy porque estoy cerca del eco. Si me muevo, no creo que me escuchen. Vamos a ver ahora. ¿Qué tal ahora? Hola, hola. ¿Me
Se
escuchan?
escucha claro, sí.
¿Mejor
Sí,
o
se le
no?
escucha igual, mister.
Pero igual como de la patada, se escucha bien, se escucha mal.
Se escucha bien ahorita.
Ah, ok, perfecto. Pues. Es más que todo probando, probando. Well, I was saying, in which part, what was the last thing that you understand? The first one or the second one? Or we're talking about the problem?
Eh, Cuando ya estaba resolviendo el problema.
Ah, okay.
Sí.
I'm saying we have the container, okay? And we can assume with practical models, the container, we can give the shape of the cylinder, okay? In this situation, we have two situations. At the depth of this cylinder, this filled with water, with the layer or depth of 20 centimeters with water. For that reason, we have a measure cover that will be 0.20 meters from the water. And after that, we're supposed to have a little layer, sorry, or take of oil, right? The oil has a depth of 0.30 meters, but I was explaining you that by the properties of the oil and water, the oil and the water can never mix between them, okay? So we have a barely separation between oil and water. And what the problem asking for, what is the, the absolute pressure of the bottom of the container. Why absolute pressure? Because at the top of this container will be open to the air. I mean, open. This is an open container, and we're going to include the pressure, the air pressure. Okay, and I'm saying we have the density of the oil in the tables. Okay, but if you see, we have a specific gravity. And explaining the specific gravity is the quantity of water that is in presence for any liquids. Okay, so we're going to use the equation, the specific gravity, to try to find out what will be the real density of the liquid. Okay, so specific gravity equals density of the liquid divided by density of water. And because we're looking for liquid density, this is divided, passes to multiply. And we are replacing is 0.7 times 1,000 kilograms per cubic meters. Okay? Testing. Once again, can you hear my voice?
Yes.
All
Yes, we
right.
see.
Okay, then. So the liquid density in this occasion will be 700 kilograms per cubic meters. All right. And remember, the density of water is a constant value given by 1,000 kilograms per cubic meters. Okay, what we're going to do, remember the Pascal principles. Absolute pressure will be equal to um, air pressure, or I mean atmospheric pressure, plus gauge pressure. And the gauge pressure can be calculated in two ways, in function of depth, density, gravity times height, or force divided by area. For simple logical words, we're going to use, to find out the gauge pressure, obviously we're going to use the first formula because we had the depths, all right? So the next step of this problem will be using this gauge pressure or the P gauge, all right? This gauge pressure will be the addition between the pressure of the water plus the pressure of oil, okay? In simple merely words, density of water, gravity, height of the water, plus oil density, gravity, oil depth. As soon as you can see, we can take a common factor that will be the gravity, and we got density of water, height of water, plus oil density, height, oil depth, or oil the height. Okay? Understood until this far? Understood?
Yes, yes.
Okay then. So let's calculate the P gauge. The gravity, 9.8 meters per second square. I'm going to use bracket because that will be healthy, nice to do it. Okay. Density of the water will be 1,000 kilograms per cubic meters multiplied by the depth of the water that will be 0.20 meters plus density of oil or oil density that will be 700 kilograms per cubic meters multiplied by that depth, oil depth, that will be 0.30 meters. Close parentheses, close brackets. And now we can try to solve it by the gauge pressure. Okay. Ta, 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 ta. I'm going to move the camera a little bit downward because you cannot see that anymore. Better, right? Well, la, ta, ta. Excellent. Well, that will be 1,000 times 0.20 plus 700 times 0.30 close parentheses multiplied by 9.8. For that reason, the gauge pressure will be 4,018 pascals. Pascals. Remember, we have kilograms per square meters because meters with cubic meters cancel. We have kilograms meter square multiplied by kilograms meter second square is Newton. Newton over meter square is Pascal. Okay. Now, because we have the gauge pressure, finally, we can find out what will be the absolute pressure. So the absolute pressure will be PO plus gauge pressure. In that situation will be PAB is equals. PO is the constant value. 1.013 or 1.013 times 10 at the fifth power pascals plus 4,018 pascals. For that reason, the absolute pressure at the bottom of this container will be given by 105,000 105,318 pascals. And that's all that we have to do in this problem. Understood? ¿Entendieron?
Sí, pero es que hacerlo solo es difícil.
Son los conceptos, los conceptos, los conceptos. Pero no es difícil. Miren, el detalle es que siempre vamos a utilizar esa ecuación de presión absoluta cuando el recipiente está abierto. Si el recipiente está totalmente tapado, no incluye la presión del aire. Así de sencillo. Ta, 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 tará. Bueno, vamos a hacer otro. Mientras tanto copian eso, me avisan, voy a ir borrando la pizarra por el otro lado. When you finish, let me know. Da, da, da. Tu, 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 tu. Esto es facilito, muchachos. Solo la práctica es el maestro. En la noche voy a, aparte de los links de la clase, de los que pueda subir, porque YouTube me tiene bien restringido, que solo me deja subir a lo mucho 9 videos por día. Voy a añadirles también otros links alternativos que pueden ayudar al complemento de estudio de la clase. ¿De acuerdo? All right, problem number 2. When you're finished to copy this one, let me know, all right? Solo me avisan. The problem number two. This is going to be a nice problem. I think you're going to enjoy this problem. Piston one. Piston one. Piston one. Piston one in figure. Okay, has a diameter of has a diameter of 0.25 inches. 0.25 inches. Period. Or period, punto y coma, period, comma, bueno, punto y coma. Okay. Piston two. Piston two has a diameter of 1.5 inches. Has a diameter of 1.5 inches. Okay. Period. In the absence of friction, in the absence of friction, determine the force F. The force F necessary to support necessary to support the 500 pounds weight. Me dicen cuando pueda cambiar la vista de la pizarra, muchachos. ¿Vieron?
Ya la puede cambiar, mister.
Ya. Ah, ok, ahorita. Ta, 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 ta. Tu, 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 tu. Venga, ve. All right. Bueno. Yeah. And I'm going to draw up the picture, the problem. Esta es una de las cosas que yo extraño de las clases presenciales. Cuando habían dibujos así, de bonitos, ponían ahora a los alumnos que lo dibujaran. La pizarra. Ajá. Tito más abajito. Un terpecito de 500 libras. Déjenme ver. Ok, excelente. Estamos esto aquí. Ahora vamos a hacer el otro. Ajá. Ta, 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 ra. Ujú, ujú, ujú. Ta, 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 taran. Ujú, ujú. No, me equivoqué de esto. Ujú, ujú. Ujú, ujú, ujú. Ujú. De hecho, hay una mano ahí que hace esta fuerza F, pero no voy a dibujar la mano, muy difícil. Así que solo me voy a limitar a colocar este vector de aquí y le ponemos la F de fuerza. Me costó trabajo, así que no se quejen. No, no está tan feo el dibujo. Sara. Okay, that's the this is the picture of the problem. Either way, if you really want to see that one, is the problem in the chapter 9, problem 28 of the Survey book. You're going to find out that that book in EduBox platform. Okay, so let's going to read what is the situation on the problem. The problem says piston number one in figure has a diameter of 0.25 inches, and piston number two has a diameter of 1.5 inches. If the absence of the friction determine the force F necessary to support the 500 pounds weight. Okay, as soon as you can see, this is like a piston. The internal mechanism in this situation is water. That's why I'm painting this picture using the blue marker that will be represent the water. Okay, as soon as you can see, my dear students, this is what we call like a mechanical ideal mechanical advantage. And this ideal mechanical advantage established that the pressure they're going to apply in the input will be the same pressure to apply in the output. For example, you have a car and you have a flat tire and you really want to change this tire, right? We're going to use the jack. So you put the jack in one singular position and you apply some kind of force, the meaningful force at the beginning, and that jack will be multiplying the force at the end. In simple merely words, in that Pascal principle, remember, says the pressure will be transmitted on the mesh to every point of the fluid. What does that mean? That means the input pressure that will be equal to the output pressure. This is simple merely words that we're talking about in the Pascal principle. What I'm trying to say, the thing that I'm trying to say, my dear students, is the pressure we're going to apply in this section will be the pressure to this section. Input pressure, output pressure. Okay, so according to the Pascal principles, P in equals to P out, right? Input, output. Why input? Because we are applying some kind of force. Okay, in this force will be produced to lift the weight of 5,000 pounds or 500 pounds. Okay, so what we're going to do? Remember the definition of pressure. Definition of pressure is the quantity force applied by unit of form area. So this is what we call force in this section. We will call force one, and this one we're going to call force two. For that reason, force one divided by area one, that will be equal to force two divided by area two. Okay, input pressure equals output pressure because it's used to lift some kind of loads or some kind of weights. Understood on this part? It's the same function when you're using a jack to lift the automobile to change a flat tire. Okay, so what we're going to do, we don't know what is the value of the force number one. And the area one, the diameter is the area of the circle. Remember the area of the circle, we have two formulas. One of them is P square radius or pi 4 multiplied by diameter square. Because we have two diameters, I'm going to use the second formula. I mean, pi for diameter 1 at the second power equals. We know what is the value of the force number 2. Of course, we know is the load. This situation will be 500 pounds divided by the area number 2. That will be pi for diameter 2 at the second power. Okay? If we are trying to solve, we find the force number 1, this quantity divided when passes to multiply can be perfectly canceled the units of pi 4. And what will be the result? The result will be the force number 1 will be the product between the 500 pounds multiplied by the product between diameter 1 over diameter 2 elevated at the second power. Understood? Onto this one?
No, mister.
Okay,
No.
Amber. In which part
In
you are losing?
in the when you started the fourth one is equal
Ah,
to 500.
okay.
That
First
part.
of all, did you understand why and equal the input and output pressure?
Yes.
Okay, then. Remember, area of circle. We have two formulas. The first one, pi square radius. This is one circle formula. And another one will be pi for diameter square. Both are the area of the circle because the shape of this point, that will be the shape of the circle. The only thing I am doing is replace area 1 and area 2 by the circles formula. Understood onto this one?
Yes, is that I didn't know where the P come from.
Okay, but this
The
is the formula.
diameter and
Yeah, this is diameter 1 and diameter 2. All right. And when it passes to divide, because pi 4 and pi 4 is the same, it can be canceled, right? And because diameter 1 and diameter 2 can be elevated the second power, instead to say diameter 1 second power divided by diameter 2 second power, we can write parentheses, both elevated the second power. Got it?
but why is it divided by 4?
Because this is the formula. Remember, the area of the circle, I'm going to write over here. We have two presentations. The first one, P square radius. Okay. Remember the concept. The diameter, that's supposed to be twice the value of the radius, right? And if I solve for the radius, diameter divided by 2, that will be equal to radius. Okay, Amber? Are you following me to this one?
Yes, yes.
Okay, then if I replace this value, the radius over here, area will be equal pi parentheses diameter over 2 elevated at second power. Continue, area equals pi d at second power, d at second power over 2 at the second power is 4. For that reason, area could be given by pi 4 diameter square. Got it?
Yes.
All right then.
Mhm.
So solving for this equation, we have 5,000 pounds, parentheses, diameter 1 over diameter 2 to the second power. For that reason, this force number 1 will be 500 pounds. Diameter 1, piston 1 has a diameter of 0.25 inches. You don't need to transform the units because we're going to divide the inches. Divided by inches, the unit can be canceled, right? For that reason, I'm not using the unit of the diameter 1 over the diameter 2. Understood, number why I didn't use the units, the inches? Because if I divide inches divided by inches, can be canceled and we don't have units. So the force number 1 can be calculated using that formula. That will be 500 multiplied by is 0.25 divided by 1.5, close parenthesis, 11 second power. So the force will be 13.89, 13.89 pounds. And the input force my dear students, even though we have the input pressure that will be equal to the output pressure, because this is established by the Pascal principle, the input force, not pressure, will be smaller, so smaller than the output pressure. Sorry, the output force. Why? Because we are using machines to lift or to carry on lift objects. For example, again, if you really want to lift a car to change a flat tire, remember we are applying a minimal force, but the rest of the force is made by the jack. Understood? Understood?
Yes. Yes.
Okay, guys, I think the climb is over, right? Or not yet? ¿Tenemos tiempo o ya terminó? Let's
No,
see.
ese ya terminó.
Ya terminó. Lástima, no terminamos. Okay, tomorrow we're going to finish the problem because this is not the answer. This is only the beginning. Hey, ¿está temblando o soy yo? ¿Lo sintieron? Mire cómo se está moviendo. No es broma, no soy yo que lo está moviendo, es aquí que está moviendo todo. En fin, ustedes ya saben, muchachos, si cae todo esto encima en la cabeza, pues te fue un grato recuerdo haberlos visto. Bueno, lo que les quiero decir que el día de mañana vamos a continuar. No sé si les trae bonitos recuerdos esta barrita. ¿Les trae recuerdos? No.
Recuerdo sí, pero bonitos no.
Bueno,
Sí, sí.
entonces, exacto, el día de mañana para resolver esa fuerza F vamos a aplicar torque o momento de torsión. Pero eso lo vamos a hacer mañana. Bueno, muchachos, Dios los bendiga, los guarde y los cuide. Pase feliz tarde. Los veo mañana. Bendiciones.
Ay,
See you,
pues,
Mr.
Bye bye. Take care of yourself.
gracias.
Bye. No se preocupe que ya les voy a mandar la foto de del problema.